Good day, gentlemen. The 4-4 here, this section is on prime factorization, greatest common factor, least common multiple. Okay, things that you've seen probably before in middle school, but back then you probably were just using wimpy numbers. Now we're going to use some bigger not polynomials, monomials with variables involved and exponents and all that kind of stuff. Okay, so let's go over the basics to get us back in the swing of things with this stuff. So the word prime. Okay, you gotta know what that means. Prime just means anything that can't be broken down at all into factors except for one in itself. So 43 here is a good example of that. Okay, so if we're trying to write the prime factorization of 43, you can't, right? It's already done for you. This is as small as it can go. Okay, because 43, there's no two integers, I should say, that multiply to 43 except for 1 and 43, right? But 35 over here, you can break down. Right, you can break that down to look like 7 times 5. You guys probably made these trees before. You're probably familiar with them. So the prime factorization of 35, since you can't break down 7 or 5 any further, is just 7 times 5, or 5 times 7. Right, you usually probably write it with the smaller number first, so 5 times 7 makes more sense. Okay, for 42 here, you break it down. We've got 7 and 6. Break 6 down to 3 and 2. Right, and so the final answer here, you need to include all three of these terms. So your final answer is going to be 2 times 3 times 7. And if you actually work out 2 times 3 times 7, hey, it comes out to 42. Alright, so the greatest common factor and least common multiple. We'll go through these basics before we jump into some examples. Okay, so the greatest common factor, right? You probably might have learned before to use these factoring trees. You might have just learned to write all the factors out and then circle the biggest one. Believe me, with the numbers that we'll be using, you wouldn't want to do it that route. You want to do the prime factorization way. So we're going to go ahead and do that. You got to get the prime factorization of each of your terms. So 8 is just 2 cubed. 12 is 2 squared times 3. And 30 is 2 times 3 times 5. Okay? Now, once you get to this point, right, the way you come up with the greatest common factor is you got to take the least power of each common prime factor. Okay? So you're just going to look at the common ones. All right, so just the ones that all three of them share. So obviously, you're not going to be able to use 5, you're not going to be able to use 3. So we're just looking at the 2 here. And since the first power here is the only one that is common, right? It's the biggest one that's common to both of the other ones. The answer to this, the greatest common factor, is just going to be 2. Okay? Now, I know this is really tough for you to understand because you look at like the biggest degree is the 2 to the thirds, but it's the biggest degree that's common to all three of them. Okay? It's got to be common to all three of them. So another way to think of it is just which one is the smallest degree. Okay, that's another way that you can kind of think about that. For the second one, okay, we got to get the greatest common factor of both of these. Okay, so if you look at these coefficients, we've got, let's see, 8. Oh, just look at 8. Sorry. So 8, when we break that down, is 2 to the third, and 16, when we break it down, is 2 to the fourth. Okay, so the greatest common factor for this is going to be 2 to the third, which is the same as 8, right? Now, in order to do the greatest common factor of variables, okay, you just got to make sure that that variable is common to all of your terms. Since a is common to all the terms, you just pick the one with the smallest exponent, smallest degree. So just a, and then b is going to be b squared, because there's a b in both of them, and squared for both of them, and c is by itself like that. Okay, so that's the greatest common factor of that one. Now to do the least common multiple, we got to use the smallest coefficient that's a multiple of 2 or more of them, and the smallest degree that's a multiple of each of them. So kind of thinking backwards, you want to pick out the biggest degree. Let's go ahead and start with this 8, 12, and 31. Alright, so once again you need the prime factorization. 2 to the third, 2 squared times 3, 2 times 3 times 5. Okay? So the way that you do this one is you have to include any prime number that comes into play at all. It doesn't have to be common for all of them like it is for the greatest common factor. Okay, so you're going to use the 2, the 3, and the 5. And the way to figure out the degree of those, the exponent, is you pick the largest exponent that appears. So this one's going to be 2 to the 3rd, 3 to the 1st, and 5 to the 1st. So the answer to the least common multiple of 8, 12, and 30 is 2 cubed times 3 times 5. And when you multiply that out, we're going to get 8 times 3 is 24 times 5 is 120. So the least common multiple of those is 120. I know this is confusing, so bear with me. Okay, this other one here, we've got we got to do the prime factorization again. So we got a is 2 cubed and 16 is 2 to the 4th. Remember, you just pick the biggest one. Okay, we've got a negative 16 here. Right, we got a negative 16. So even if you have a negative in here, it doesn't matter. Okay, your coefficients are always going to be positive. Look here at the bottom. Coefficients are always positive. Doesn't matter if it's positive or negative. Okay. So don't let that confuse you. So you pick the biggest one. We know that our number here is going to be 2 to the 4th, which is 16. And now to get your A, B, and C in there, right? They don't have to appear in all of them. Luckily, the A, B, and C do appear in all of them, so that's fine. Okay, but you pick the one with the largest exponent. So not going to use a to the 1st, you're going to use a to the 3rd for this one. So a to the 3rd, b squared, c to the 3rd. Okay, that's greatest common factor and least common multiple. Let's go into the examples. So we got to get the prime factorization of 924. We got to start breaking that down as much as we can. Now everybody knows that 924 divided by 11 is 84. Okay. So you can keep breaking down from there. The 11 is as a prime number, so you're going to keep breaking down this 84. Okay, you could, let me think, we could do, let's do 4 and 21. Okay, which goes down to 3 and 7, which ends that, and this is 2 and 2. Okay, so at the end here, we've got 2, 2, 3, 7, 11. All right, we got to put all those together, and we'll get 2 squared times 3 times 7 times 11. That's the prime factorization of 924. Okay, you could do the tree like that. You don't have to do it that way. Whatever works best for you. All right, now greatest common factor, least common multiple. Let's get these done right away. Okay, so we've got 20 and 28 here. Of course, if you have your own method, go for it. I suggest you do the prime factorization, though. So the prime factorization of 20, you should get 2 squared times 5. And for 28, you should get 2 squared times 7. Okay, so remember for the greatest common factor, GCF, what you got to use is you got to use the smallest exponent for each common factor. Right, remember, they got to be common. Right, so the 5 and the 7 are not going to be used, just the 2. So the greatest common factor here is 2 squared, which is 4. All right, and then to find the least common multiple for this, you don't use just the common factors, you use all the factors. So we're going to have a 2, we're going to have a 5, we're going to have a 7. All right, 2, 5, and 7 for the common ones. All right, you're going to use the biggest exponent that shows up. Obviously, it's just still going to be just 2 squared. So you should have 2 squared times 5 times 7. Okay, which is 35 times 2 is 70. Well, I guess we could do 4 times 5 is 20. 20 times 7 is 140. Okay, so the greatest common factor for those two is 4. Least common multiple, 140. Now, a little bit bigger numbers here. All right, for a little bigger numbers, you're going to do literally the same process. All right, we got to break them down. Okay, 100's very easy. We've got 10 squared, right, well, I guess I don't need to write that part. You guys could do this part on your own. Okay, so you have 10 squared, which is 2 times 5, so we'll have 2 squared times 5 squared, 120. It's going to be 10 times 12, which should be 2 cubed times 3 times 5. 2 cubed times 3 times 5. 2 cubed times 3 times 5. because that'll be 15 times 6, which, yeah, hold on. Oh no, 15 times 8. Okay, good. I did get it right. And lastly, here are 90. Okay, you have 9 times 10, which is 3 squared. 2 times 3 squared times 5. All right. Now, there's all of our prime factorizations. Now we can come up with the greatest common factor and the least common multiple. Okay, so in order to do the greatest common factor, you've got to find just the common terms. Okay, so the one that we're not going to use for this one is the 3, because it's not in all 3 of them. We're going to use the 2, and we're going to use the 5. All right, now with those, we pick the smallest exponent from each of them. So it's just going to be 2 and 5. So 2 times 5 is 10. That's the greatest common factor. And for the least common multiple, we're going to use all of them. We're going to use the 2, the 3, and the 5. And you're going to pick out the biggest exponent. So it's going to be 2 cubed times 3 times 5 squared. Oh, which is incorrect, actually. I made a mistake back here. The 90, it should have been 2 times 3 squared times 5. Totally messed that up. My bad, guys. So it should be 2 cubed times 3 squared times 5 squared, which is going to give us 8 times 9 is 72, times 25 is 1800. That makes so much more sense. Okay. So the greatest common factor of those is 10, least common multiple, 1800. Now, on to the monomials. So we've got this 8ax squared and this 12a squared x. Okay, so we got to find the greatest common factor and least common multiple of 8 and 12. So 8 is 2 cubed. 12 is 2 squared times 3. And in order to get the greatest common factor, you got to look at just the common ones. Take the smallest exponent. It's going to be 2 squared is 4. You guys should know that just from looking at it. And the least common multiple for those, you got to use the biggest exponent from both of them and use everything. So we've got 2 cubed is 8 times 3 is 24. Now we got to add our exponents. For the greatest common factor, you got to use just the common ones and the smallest exponent. So that's going to be a and x. And for the least common multiple, you use all of them, not just the common ones, even though they both have an a and an x in them. And you use the largest exponent, so that's going to be an a squared and an x squared. And that is the answer for a problem like that. Now number 5 here, we're dealing with a little bit bigger numbers. We're going to break those down. It's going to be 16 times 2, which is 2 to the, it's 2 to the 5th, obviously. Okay, so we got 2 to the 5th for 32, 120 here. We can do 12 times 10, which is 2 to the 3rd times 3 times 5. And 42. 7 times 6, so 2 times 3 times 7. Okay. Now the greatest common factor, least common multiple part of it. Alright, let's do the numbers first. In order to do the numbers, we're going to do the common one, smallest one, right? So it's going to be 2. And then for the least common multiple, we're going to use the biggest one. We're going to use all the numbers, so it's going to be 2 to the 5th times 3 times 5 times 7. Let me write that out for you. 2 to the 5th times 3 times 5 times 7. Real big, so you should be able to type in your calculator. I'm going to do it on my calculator because I don't know that off the top of my head. It's going to be 2 to the 5th is 32 times 3 times 5 times 7. We're going to get this real big number, 3360. 3,360. Hopefully I did that right. If not, I apologize. Okay, in order to get the exponents part of it, okay, we're going to look at the common ones. They've all got an x, they've all got a y. Take the smallest exponent out of each of them. So x by itself and y cubed for the greatest common factor. And for the least common multiple, we're going to look at all of them. So it's again x and y. We're going to pick out the biggest exponent we could see for each of them. X cubed, y to the 4th. And that would be the correct answer for both of these. And lastly, number 6. I just threw this one on here so that you guys just had one to practice on your own, where you didn't necessarily have all the same variables, okay? So just a hint, I want you guys to do this on your own, but a hint, your greatest common factor is not going to have a y in it because they don't all share it, but your least common multiple will. Okay, good luck, and I'll see you in class.